Hello, everyone. I hope you've enjoyed your lunch and you will enjoy my talk as well. So my name is Leonid Startsev, and I've been working for Kotlin libraries team at JetBrains for more than 7 years. And today we are going to talk about how to not forget your values, or more specifically about a new Kotlin feature that I personally think will change the way how you look at your code and how you think about it. And I like to think that every feature in Kotlin has its purpose and it helps to solve some problem somehow. So this feature, of course, also solves some kind of problem. Let's first understand what this problem is. So let's dive into this small piece of code. We have a function called formatGreeting, and it accepts some kind of name, which is just a string. So if this name is blank, then we should say hello anonymous user. If this is a simple name that doesn't contain any spaces or anything, then we say hello this name. And if it is some complex name with probably a first name, last name, or something like that, we format a more complex greeting. So raise your hand if you already spotted the bug in this function. Great, so about half the audience. So you're right. If we run this code, trying to format greeting for name Alex, then we get an index out of bounds exception that says that we tried to access index 1 in the array which has only one element. Of course, we can ask our wonderful JetBrains AI assistant to explain this stack trace to us, or ask Juni to fix this problem, but the fix is quite easy to come up by your own. So the author of this code simply forgotten return in the second if here, and the whole expression like hello plus name replace first char plus exclamation mark was simply lost and never returned out of the function. So if we add this return here, then function prints hello Alex with a capital letter as we expected. Let's take a look at another example. So imagine we have to get two smallest numbers out of some numbers array, like here. So one of the easiest way to do this is to just sort the input list here and then access the first two elements of this array. So do you think that this time we wrote this function correctly? Raise your hand if you think this is correct. Okay, a couple of hands. So if you run this code, we obviously see that it doesn't print the two smallest numbers. It prints some 41 and 15, which obviously are not. And what was the problem here? The problem, we have two very similarly named functions in Kotlin standard library. First one is called sorted, and it works on any iterables, and it returns the new list of the elements sorted according to their sort order. And there is a very similar function called sort, which works on with mutable lists, and it sorts the elements in place, mutating the list in the receiver position. So to fix this problem, we either have to save a new list that sorted function returned to us, or to replace the sorted call with sort call. And by doing so, we get our smallest numbers like 2 and 4 out of the list. Well, you may say that it is a silly mistake, like I will never do this myself, it's so obvious. Well, this even happens to the best of us. This is a piece of code from Kotlin serialization from the test source set, where I forgot to use the return value of the equals operator. There should be an assert equals instead of a regular equals, but it wasn't there, and I had to fix this later. Fortunately, the test continued to work, so no bugs were made in production code. So what these examples have in common? They do not perform any operation with the call result, whether it is a plus operator or an equals operator or a sort function call. All of these mistakes, they have the same root cause. The author of the code didn't use the return value of the call. So the resulting string or boolean, it was simply forgotten and thrown away. Now, this is something you have to keep in mind, especially when you want to get away from exceptions to more like result-style programming. Imagine if you have function that creates user and returns a result, and if database insertion is successful, then we return result success, and if not, we return result failure with some database exception. And if we call this function and do not check its return values, then we simply lose an exception. We simply lose our error. And this may result in some strange consequences for users, or like even losing their data or something like that. And if we move forward with the rich errors, as was explained by Michael in his yesterday's talk, hope you visited it. If not, watch the recording. It is really great. So if you have the new proposed union types of with errors, then this problem still persists. We still have to check the return value of create user function to check whether it was successful or it returned some database exception. Because without it, it will be quite useless, to be honest. So, okay, now let's see, can we prevent this? We have our wonderful IDE with a lot of diagnostics and quick fixes. We have our wonderful compiler. Maybe it is smart enough to just warn us about every unused value we forget. Like, so if function returns unit, it is okay. If function returns not unit, then probably it's mistake. Yes? Well, no. Fortunately, it is not always true, because we have some amount of functions which return some values which are maybe not that useful. For example, a mutable list add. It returns Boolean, and almost no one ever uses this Boolean result unless it is required by some special logic. A lot of things like string builder, append, or similar functions just return this for the purpose of chaining the calls. But if we forget this string builder or do not use it later, it is completely fine. It is not a mistake or not a bug. And there are a bunch of other functions as well. So in general, all functions can be divided into categories. So there are results which are supposed to be used, and there are results which are auxiliary, these functions. And only author of the said function knows its purpose, the purpose of the result. And the author has to mark these functions accordingly. Because for compiler alone, it is impossible to deduce just by looking at signature of mutable list add that its Boolean result is can be easily forgotten, can be simply forgotten, and it's not that useful. So, okay, we found out that it's not that easy, but maybe someone already solved these problems. Let's take a look at existing solutions maybe in other languages. So Rust, for example, has a must-use attribute, which does essentially what I just described to you. It marks some functions and instructs the compiler to emit a warning if the said function result wasn't properly used. C++ also has a similar attribute called noDiscard, which does the same. And of course, Java has a lot of linters and a lot of annotation packages for this purpose. One of the most popular of them is an error-prone annotations package and linter authored by Google. It has this check return value annotation you may be familiar with, which also says that the result of this call must be used, and the linter will emit a warning if it is not used. And even a third-party linter for Kotlin, detect, also has similar rule, which works with the same annotation and can warn you about your Kotlin code if it is annotated properly. However, there is one solution that stands out among them, and it is coming from Swift. In Swift, they have this attribute, also for marking code, but it's called discardable result. And the crucial difference in Swift is that all functions in Swift are implicitly check return value by default. And the attribute discardable result serves the inverse purpose. So it instructs the compiler not to emit a warning, while compiler will emit warnings on all the functions by default, except the one that has this attribute. And this inversion of default is very important in our opinion. we think that must use has to be a default state for all the functions, because both JetBrains and Google search shows that the majority of functions, like 85%, have results that are supposed to be used and that cannot be simply thrown away. And functions like mutable list add or string builder append are only like maybe 20% of all the functions there in the world. So by assuming that the must-use return value is a default state, we can catch more bugs at compile time. We can improve the quality of our code. And we can improve code maintainability, because it's quite much more easier to reason about the code when it is either explicitly used or explicitly dropping the value, instead of just leaving it out in the wild. You may ask me, if we already have a bunch of linters for Java and Kotlin, why should you make it a part of language? Well, the answer was in the keynote by Vsevolod, because modern programming languages are not just compilers, they provide ecosystem. We have our own documentation engine, we have our Gradle plugins, we have our coverage tools and binary compatibility tools. And this problem is, in my opinion, is severe enough to have its own place among compiler diagnostics. And besides that, once upon a time, Kotlin already addressed a similar severe problem, turning a bunch of linters and annotation packages into a simple string question mark notation. Yes, I'm talking about knowability. Knowability handling was a cornerstone of Kotlin 1.0 design, and it is still today. And I think if I could go back in time and tell Andrei Breslov that, hey, you should not only solve the problem of knowability, but also think about using the return values and checking it properly, I think he would agree. So, now that when we identified our problem, we can determine our goal. So our goal is to report every useful value which is unused somehow. Let's take a look at the details of this goal. So what is useful value, what is used, and what is unused? So what values are not useful? Obviously, these are function values that are either unit or nothing with question mark, because you can't do really anything meaningful with them. There are function calls that are marked as ignorable, such as mutable list add, and we will go into talk how to mark them a little bit later. And besides that, almost everything else is useful except some expressions that have known side effects, such as comp out assignments, a plus assign operator, and so on. So using the value is also kind of intuitive. So, right, if we have some format greeting function which returns string, we can use the result, this string greeting, by passing it to another function, for example, such as println. Using it as a receiver in the call is also obviously using the value because it is not lost, it is passed further down the call stack. We, of course, also have initializers and returns, whether you assign this value to some variable or return it out of the function or throw it if it's an exception. And you also using it somehow. And we have operators and conditions, because if we put this format greeting into the if condition position, then we compare it with some value or with Boolean, with true, and it is also useful to us in some way. What may be not so intuitive is that you should remember that the last statement in the lambda also has implicit return. So when you're writing such calls, such as format greeting down below as a last statement of let, you're using it, transforming it into the whole result of the let block, but not if it is not the last statement. If it would be in the middle, then it would be lost. So, okay, this seems quite easy, and probably like 2 days of work, but surprisingly, it is not enough. Why? Oh, let's take a look at this piece of code. So here we have a format header function, and we do some tests. So if it is a new user, then we should format some greeting. But if it is not a new user, then we just return some string like welcome back. So what's the problem here? That we actually didn't greet anyone. So we call the format greeting function, but and it returns some string to us. But because the whole if expression just hangs around in the air, it is not used in any way, so we lost this value. And to fix this problem, we need to somehow use the whole result of the if block. So whether we can assign it to variable, we can return it, do whatever we want, but we have not to leave it away. So and the position of format greeting here is not changed. It is still just a branch of an if expression. But the difference is that the whole if expression is now in the used position. So this leads us to a concept of propagation. Propagation is for expressions that cannot be ignorable or non-ignorable on their own, and their ignorability is determined based on their sub-expressions, or arguments, if you want to call them so. Alternatively, you can think of them as expressions that propagate the ignorability up the expression tree. Like, as an example with if, we have outer expression and inner expression. So if outer expression is used, then the inner expression is also used. And if the outer expression, the whole if, is not used, then the inner is also not used. And we have to keep this in mind, because we cannot decide here for format greeting function call alone. We have to access outer context. So same with when. If we, for example, have this case when is not used in any way, then the expression A is used because it is a condition, it is compared with something. And here B and C are not used because we forgot them. And here, because the whole when is assigned to some variable, both A and B are correctly used. So category of propagating expressions is not big. It consists mainly of control flow expressions, such as if, when, and try catch, and always separator. We have also type operators that behave similarly to control flow, like as, is, and double bank. And there's also certain lambdas, like Kotlin.let, which they may be seem to be out of place here. So you may ask me why lambdas should be propagating. Not all of them, by the way. So let's take a look at Kotlin.let. So we have some function, let's just call it getString or null, which returns nullable string. And then we use a safe call let on it to return hi plus it, the string, whatever. So obviously we want to not to lose the result of the computation, the hi string. Right, so this whole expression has a type of nullable string, and we can warn a user if this let is not used, like, hey, you forgot your string. Okay, great. But what if we have another expression as in the let lambda? What if we have some kind of ignorable function, like string builder append? So again, the whole type of this outer expression, it's not unit. It is string builder with question mark, nullable string builder. And according to our rules, we should warn the user about that. But string builder append is not a useful value. It is ignorable and marked so. So in this case, we of course can try to mark that as ignorable as well, but in the, we will lose warning in the upper case. So in reality, we should somehow propagate the fact that append here is an ignorable function call, and we should propagate it outside the let lambda to propagate this ignorability to the whole expression. That is why it is also a propagating expression, just an if block or an always separator. So I was talking about that string builder append is marked as ignorable function, because we know that its result is not very useful. So how can we do so? Well, we have our favorite code markup tool, and it is, of course, annotations. So we will add a new annotation to Kotlin standard library called ignorable return value, which you can use to mark your builders or other functions that you think shouldn't be always checked. So, of course, maybe in future Kotlin it can become a keyword, but since I'm not in the language evolution team, that decision is not on me. What language evolution team agreed to, though, is that we need some special syntax for cases when we do not need the value explicitly. So our proposal comes with a part about unnamed local variables. It is a new syntax addition for Kotlin, which allows you to use val underscore as indication that the value explicitly is not used. So in our example, in save to database function, it returns string, and the author of this function legitimately thinks that this string result must be used somehow, and he's correct in that way. But in a place where we use this function, we may not care about whether it was successful or not, maybe because it's some kind of fallback or test code or whatever. So we have our save or whatever function. And to indicate the fact that we really didn't want to use this function, and we do not want to get a compiler warning here, we can use val underscore to declare unnamed variable and to explicitly drop this value returned from save to db. Well, first of all, it of course suppresses unused return value warning, but it also helps anyone who will read this code, because if there would be just a call a save to db function, it looks like a potential bug or missing value or something like that. But if we have val underscore here, it greatly helps readability, and it helps to understand what author of this code meant. So now that we talked about our goal and our new feature, the unused return value checker, let's talk a little bit about how we are going to deliver this to you, our users, and our general vision for the roadmap of this feature. Of course, we want to live in an ideal world where every scope is automatically checked, all functions are must-use value implicitly, ignorable functions are clearly marked with annotations, and so on. For example, if you would have such a class as myBuilder with addString function that returns this, you will get a warning here trying to call an addString. And you can easily fix this just by adding a corresponding annotation, ignorable return value on the addString function, and the warning is gone. Great. But we live in a real world, and in a real world, people not always write code themselves. Of course, we have AI now, but even before AI, people didn't write all the code by themselves. They use this thing called libraries, right? And, well, being in Kotlin libraries team for 7 years, I know a thing or two about libraries. And, of course, if such class as myBuilder is in your dependency, you cannot simply go and add an annotation there. You can probably go to a GitHub with this library, make a pull request saying, hey, this new cool annotation added to Kotlin, you should use this. And probably your pull request even can be merged. But then you need to wait for the release of the new version, then update it, and so on, which is, well, a considerable amount of time. So we need a better solution. Because most libraries are not yet annotated with our annotations that we just put there. And Kotlin has grown significantly since 1.0. We have a lot of libraries written in Kotlin already. And contrary to the 1.0 release where knowability was just introduced, we have a massive community. We have a lot of libraries already. And some libraries are not afraid of experimental features and are able to migrate fast as soon as we make a release with this feature. Some libraries, however, may be slower to migrate and want to use exclusively stable Kotlin features. So it will take some time for them to upgrade. And adoption may lag for years, and some libraries probably never will be updated, or they do not want to interact with Kotlin annotations and everything else. Like, we can just go and put Kotlin.ignorable return value on some 15-year-old Java library, right? So we need to clearly differentiate between libraries and packages that are ready to be used with checker and that are not. So when the library is ready for our used return value checker, when it is having ignorable return value everywhere it is supposed to be. So, like in my builder example, if author annotates everything in the library that is ignorable, it can be safely checked by our new checker. And only author of the library knows whether their library is ready or not. So they have to mark it somehow. And, well, how to mark library is ready if you're an author of it? Well, to enable corresponding Kotlin compiler setting. So this feature, unlike most of the new features, will have 3 state switch. Instead of just enable disabled, we'll have, of course, disabled state. We will have a checker state, which will check only libraries that are marked as ready with the corresponding checker. And we will also have a full switch, which assumes that your code is ready to be shipped, that you placed ignorable return value everywhere it is supposed to be. So by using this switch, we can draft up the migration plan for the whole ecosystem. So the first step is that a library author inspects their API and annotates it with the ignorable return value accordingly. The second step, they release a new version of the library, which is checker ready now. Then the library clients can safely enable the unused return value checker to get warnings about misusages of checker-ready declarations from this library. And when all the warnings are gone, and the library users annotated their code as well, they can make a checker-ready version of their code and then distribute it further to their clients and spreading this checker-ready state. Then you go to step 1 and you repeat everything again until the whole ecosystem is migrated. So how we are going to mark the library exactly? Well, there are several approaches. The first approach is it will be automatic. So compiler will do everything for you. Just take your library, turn on the full checker mode, make sure that you have no warnings, and ship it. And your clients with enable checker will be happy immediately. Of course, if your library is big or you want to do a smaller chunks migration, we also have an annotation for you. It's called must use return value. And you can place it on APIs you want to be checked now without opting in by the whole model with the compiler settings. But in practice, it is not very convenient, and because we want every function to be must use by default, we urge you to try the automatic approach first and use must return value as a fallback. However, having a recognizable annotation for such cases is a plus, because we can also understand some other annotations. For example, a lot of existing Java libraries, such as Guava, they are already annotated with Google error-prone annotations, such as check return value I showed you in the beginning. So if you will able to understand them, just as Kotlin's must-use return value, then we will have a safe more safer interop. So we will be able to report both improperly Kotlin-used functions and functions that are coming from Java. And there is also a big JSpecify proposal that has potential to unite the whole ecosystem. It also proposes must-use return value or similar annotations. And if Java libraries will adopt it, and then Kotlin code will get safer as well, because we will be able to recognize them. So I hope you're excited for this new feature as I am. And if you're excited, you can ask me, can I try this feature today? Well, almost, yes, because all annotations in mode, they are already available in the Kotlin master, and they will get into the 2.2.20 release, which beta 1 version will be coming out really soon. So you can try to enable experimental checker with -x return value checker check, or try full mode with return value checker full. So, and Java interop and annotated Kotlin X libraries will be available later this year. We are working right now really hard to annotate everything ignorable in stdlib, so you can try this feature and immediately get some warnings whether if, for example, if you forgot to use the result of a sorted function. So what's next? We will be trying to release this feature to the stable state as soon as possible when we will iron out all the quirks. So, and stable checker will not compile everything in the full mode because it will be too broken for the ecosystem. But stable checker will always check decorations compiled in this mode or annotated with must use return value. Oh, yeah. It means that all users will immediately benefit from Kotlin standard library and Kotlin X libraries being annotated. Because even if they do not enable anything themselves, Kotlin stdlib will be compiled in full mode, and users will, with the checker enabled by default, will get warnings about forgotten results of plus separator, equal separator, sorted, and everything else. So, of course, we have our detailed proposal available in Kotlin skip repository. You can scan your code, read the detailed proposal, leave your comments if you want. Yeah, take your time. The QR. So, yeah, that's all from me for today. Thank you very much for coming, and don't forget to vote for the talks.